Well, I'm Tom Burgin. I work for the National Institutes of Health as a contractor. Do a lot of Mac management, MacAdmin, Mac engineering, a little bit of development. So I'm going to go over some of the things that we're working on, and hopefully we'll have some fun, learn some things. A couple ground rules of what we'll be going over. Let me see if I can get my mouse. First session, which is this one, hoping to make it through the shell in Python for OS X and third-party scripting updates. We might not get through all the way of the Casper quick add for other management platforms. We'll see how far we get through. I kind of want this to be a discussion, so if you have a question, just raise your hand and we'll get you a mic so we can go through this. It's a lot of content, but I think it would be best understood if you ask questions throughout instead of holding them to the end. So just, yep.
So just one real quick question, since some of us can't take notes easily. Is this being recorded?
I believe it is. And the PowerPoint, the keynote, will be up on GitHub, so you guys can grab that later.
I just want to mention that if you have a question and you want it to be captured on the video, you need to use the hand mic to ask your question.
I could also just repeat your question if you just wanted to raise your hand and shout it out. There's a lot of people here. That works too. Then the second session, after our break, we'll finish up whatever we don't finish up with Casper's quick add. And there's a lot of you here, so it might be kind of difficult, but I wanted to basically people bring questions, whatever they had on with their scripting, kind of give some examples if you had any things you're stuck on or things that we can kind of go over there. And if no one has anything, we'll just go over some other tools that we've been working on and try to have some fun with shadow hash data. Okay, so the tools used in this presentation, PyCharm, Community Edition, it's great. IDE for Python, it's free. Python Tutor, this is an amazing tool that allows you to visualize what's going on in memory with Python. So you can essentially take your Python script, pop it in this web page. It's pretty limited, it doesn't have I/O and things like that, but it allows you to really get a good idea of what's going on in the script throughout the runtime. You can go back and forth. So I'll be using that today to show you some examples. Xcode, Text Wrangler, Terminal, my GitHub, and also Hexfiend. All right, why script in OS X? Basically, this is what the whole speech is about, but we're going to get into interacting, configuring, manipulating the behavior of OS X, packages and other applications. Typically, when you think of scripting, you don't think of app development, you don't think of object-oriented programming, but Python, the tool that we'll be using most of today, it's pretty cool because you can use it for a quick script to manipulate some things, to install a package, but you can also write full-scale object-oriented applications with it, with things like auto package. You've seen Greg Nagel's great work and some of the other folks that are here with those types of things you can use with Python. And a little pun here, you can literally create a .app with scripting, and we'll go into that later. But. Okay, so this example, we'll just go through one quick Python example of a script and one quick Bash example. Some of what we're doing might seem exhaustive. We're going to go through a lot of examples and kind of step by step throughout some scripts. And I am by far not the smartest guy in the room here, so I know there's probably much better ways of doing some of the things I'll be showing you. This is more of an educational purpose to show what you can do with these types of tools, and for you to be able to take those ideas and make them more efficient is what it's all about. And if you do have a better way, go ahead and shout it out, and we can kind of go through that and everyone can learn. Okay, let's go through a Python script. First, we'll start with this executable called last. When you run last, just in a terminal shell, you get a bunch of information. So if we were to consider first what you could do just in the terminal, you could read and kind of count how many users have logged in, see who is logged in at this time. But what if we wanted to get some information and make decisions based on who has logged into a system? So where we're going to go through with Python how to do that. You can kind of do some of these things with Bash, where you can use grep and awk to grab this information here. However, does this have a laser pointer on it? Oh yeah, there we go. So you can use grep and awk to go ahead and get at this information, but with Bash it's kind of hard to go ahead and pull in other libraries to do some analysis on that. So we're going to use Python to use some of the built-in libraries to do things with that data. Okay, right off the bat here, there's a lot of information on this page, but we're going to explain it and go through it. So here's a very simple Python script, and what it does is it runs that last command that we just ran in the terminal, but it runs it in a Python script. So up top here we have our header information. Actually, I can't see very well, so I'm just going to stick to my screen right here so I can actually see what we're looking at, and I'll point this way. So we have our header that defines what interpreter we're going to use. Typically in Bash scripts, which there's kind of understanding what scripting is here, so I'm not going to go into too deep specifics, but basically we're going to define here that the rest of whatever else is in this file, Python is going to be the interpreter for things below it. There's other ways of setting your environment. You can set different versions of Python. We're just setting Python, which will get the default version, which in OS X 10.7, 8, and 9 is 2.7. 10.6 was 2.6, and there's a slight differences there, but we won't get into those today. We have the next line is a import subprocess, and what that does is it allows us to use the subprocess module throughout the script. It's a very helpful module that Python includes in OS X to basically allow us to run executables that are on your file system in a way that then Python can get that information out. There's lots of different ways that you can run subprocess, and we will get that to that in a second. So we're going to next define a function, and this function basically is, we call it bash command, and it takes as input one list called script. And this try block, we don't have to get into how tries and work right now, but basically what it does is it'll run whatever script did you give it, and if it's successful, it'll go ahead and give you the output of that script. So we see here that on the next line we have script equals a list, and inside that list there's just one item, and it's a string, and it points to the executable last. The way that subprocess works is you want to pass in one list with as many items that you want for the first executable. And every item after the executable is a parameter to that executable. So if we wanted to have a parameter to last, we would put comma and then have another string that would define what last would do. But we're just going to get at last. And the next final line basically goes ahead and calls that function bash command, and it passes in our list called script, and this is what we get. This picture here comes from the online Python interpreter. What I did was just basically copy and paste the string in there, so we'll see it, and we'll go through the example online so you can see what we're going to do. But basically we have a string now which includes ITSB admin all the way down to 907. And that's one big screen with new lines and everything in there. So we got to go ahead and parse this somehow. So first thing we can try to do is we can split up that string that we just got back from the subprocess. So in the last line there, you notice the arrow underneath split. What the split does is basically every item, word, or a tab or a blank line, we'll go ahead and make a new list that has every item inside there. There's not much we can do with this. This is just the same as a string, so we don't really want to do that. Let's see what we can do next. Let's go ahead and add a /n inside the split, and that basically tells us, okay, let's take this string and let's split it out for every line. So that way that's looking better. We actually have control of each line now. So within that, you can see that the list is numbered 0 through 1. 0 through 7, and essentially we'll use that next to go ahead and get at some information in that script. So basically, now that we have each line out, we want to go ahead and go further and get at each item in that line. And that's where a nice and simple for loop comes in. So we go ahead and for E in our bash command split /n. Basically, we're taking every line that's in that bash command and we're getting every element out of it. And for every element, we're going to go through a little block of code, everything that's under 4. So if is this working for you guys, or should I be pointing up here? Does that make it easier? Let me see if I can do that then. If I plug this in, it might be a little advanced for us. Oh, good. Sweet. Okay. So we have our split command. We go on to our for loop, and this allows us to take this element here, which will be split up using right here. So this right here is this right here. This is what it looks like in memory. The element has every item in that line. And now that we have that, we can call our element 0, which basically will get us this. So when we do that, we now have one user. Well, we have to do that as many times, loop through every line of the last output, and we'll be able to get all the users. So let's do that now. And by doing that, we're going to make a new list to capture every user that we get out of that for loop. So we just define a new blank list up here, and we append that list with E0, like we showed in the last command. Just printing it out gives you that one item right here. So now we have a list of users that were on the system. So it basically is the same thing as awk. It goes ahead and grabs that first column along the last output. And it allows us to now have a nice list in Python that we can start choosing and making decisions based on this list. So there's a cool module in Python called counter. It's included in the standard library, so you don't have to import anything or download anything. You do have to go ahead and import it into the script so we can use it. It's under collections and use import counter. It's also a class. From right here, you could create a new object of that, but we're not. We're just calling the class directly and grabbing this function, most common. So what we're doing is, this looks a little complicated, but it's pretty cool what it does for us actually. This most common function in the counter class goes ahead and returns a list of tuples. And a tuple is nothing more than a list that is that usually has data that's associated with each other. So we have a list of every item in the user list that we passed in before, this thing. And what it does is it counts how many times each of those items is in there. So Burgin TJ was in there 4 times, ITSP admin was in there 1, and this is just the bum part of the last command that we don't want. And the most common is actually really handy too, because it goes ahead and puts the highest count always in the 0 position of the list it returns. So you don't ever have to worry about actually going in here and finding the highest or the lowest. You know the highest and lowest is always going to be 0, or in Python you can put -1 in this little section right here, and that will get the last item. So we don't really worry about the last item here, but it's just an anecdote. So what we can do is now print, let's go back, because that actually looks easier. We can now print 0, 0, which basically means in our users list, there's another list. Sorry, your user's variable is a list. We get the zeromost position of that list, and then we get the zeromost position of the tuple that that list holds. And that gives us our most common user. So this is just a simple example of what you can do in Python, incorporating it in with running executables that are on your file system, and then being able to manipulate the data on top of that. With that, basically we can make decisions on, okay, we know who's currently logged on, but we want to know who's most commonly logged on and do something to their account. So I don't get into that now, but that's just a quick example of what you can do with Python as a script in OS X. So we'll do a quick bash example as well before we get into some packaging to show you what you can do with bash. So essentially, we have a problem. We want to make this app. An app is basically just a directory with a couple plist and typically an executable in it. We don't have an executable in this. This is a kind of a bum app. But what we want is the plist to mimic the version number to the version number of OS X. So we'll have an app that will always be able to tell us the version number that we're running at the level of OS X that we're running. The reason we need this, if any of you have used Absolute Manage, does anyone use Absolute Manage here? One person. And it might be helpful in Casper, I'm not sure, or other types of management platforms. Absolute Manage does really good about allowing us to make decisions based on this number, but it doesn't do anything with decisions based on this number. So say if we have a patch that basically only applies to 10.9.3, well, not to 10.9.2, there's no way in Absolute Manage to tell it to only run in our 10.9.3 systems or 10.9.2 systems. So with this, we're able to create a application that Absolute Manage can be constantly querying for the version number, and we can basically set a information item up to do this automatically, kind of like you would in Puppet. It just every 30 seconds it checks to make sure that this little script has run, and then you can make decisions based on that last version number to install certain packages or what have you. So within about 30 lines, we can basically create an app out of thin air that has that version number. The app obviously doesn't launch or do anything else besides sit on the file system and references the version of OS X that you have. There's a plist that you guys are all probably aware of called system version plist in the core services that has the item that basically tells you what version your OS X is running, but Absolute Manage has no way to parse plist and make decisions on that. It does have the ability to look at an app, give you the version number, and make decisions on that. That's why we're going over this. So I'm going to go back here. First, we need to define, like in Python, define what type of script it is. So we give it the bin/bash or bin/sh header there, so it defines the interpreter. And then someone besides myself wants to use this script, we go ahead and drop in a nice, easy variable for people to change. I put it in library/receipts. Seemed like a fitting place to store something like that, but you can put it anywhere. Now, we're going to define some functions. Like in Python, functions are defined, but they're not run until they're called. So when we define this main function, all that bash is doing is reading it in and then waiting for you to do something with main. You will get errors with running a script if there's something wrong inside main, but it's not actually going to do anything until you call it later. All right, we'll go through this line by line real quick. So we have our main function here in bash. It's similar syntax to Python, but it's a little different how you define these functions. So basically, we go ahead and look for the path that we defined earlier, which is %1, is we're going to pass it into main, and it'll be the first variable that main gets run with. And we're going to look for the OS version.app folder that we created. If it's not there, it's going to go ahead and run another function called create app, passing in that file location that we defined earlier, and we'll define that function in a second. But if it is there, so if this is a folder on our operating system, then we're just going to do 2 lines to basically put in some information into that plist that basically tells the file system what version that app is. And we use plist buddy for this. Super simple. We just go ahead and tell it the CF bundle short version string, which is the field that Absolute Manage looks at when it wants to make a decision based on an app. And we call this executable SW production version, and that will return a string value 11093 or whatever you're running. Also, real quick to know, it's kind of hard to see, but these are backticks. They're like right underneath the exit button. And in Bash, when you put something in backticks, it executes it and returns the value of that executable for you. So this essentially will be on this system 1093 in the end. So it'll be 2 quotes 1093. And then we just show plist buddy where we want to go ahead and put that, which plist to write that value to. And then this is something a little tricky I had to figure out. I'm not sure if anyone else has run into this. When you're in a .app on your file system, if you don't really touch, if you don't touch anything besides the info.plist, it doesn't update in Finder the version number. So when you're clicking on the app in Finder, you'll see the version number 1093. It won't actually update to what you changed it to until you actually go in and touch something inside of that directory, and then all of a sudden HFS picks it up and then displays whatever it needs to display. So. Okay, we already went over that. Here's the create app that we called earlier if that folder doesn't exist. Super simple. It just makes the directory contents. There's faster ways of doing that, but I wanted to be explicit. And then it does the same thing we did earlier with go ahead and enter that CF short bundle version string, and then it adds just some more information just under the readable copyright if it wanted to put it there. So super simple. In the end, you get we actually have to run main. So like we said earlier, those functions don't actually run until you go ahead and call it. Okay, so let's get into packaging. So those are things that we can do with scripts. Scripts can be super informative to what's going on in the system. It can create things, it can manipulate things. But what we're going to do is basically leverage scripting and put it inside of a package to do something. We're going to be going over modifying the Cisco AnyConnect package that you get from Cisco. Who uses AnyConnect SSL VPN here? A lot of people. Good. We use it a lot too at NIH. So the problem is you get this from Cisco, and they give you a little place where you can put some profiles, and it'll pop in the Cisco profile into the opt directory, and then that will manipulate some of what the Cisco application is doing, but there's not much else the package does for you besides install the Cisco AnyConnect software. So what if you wanted to update the dock icon from the older version to the new version right away? And we can do many other things with script, but that's what we're going to go over. Basically, we're going to go over installing different versions of the profiles for different circumstances, and then a dock icon updater. And it's all going to be embedded inside the package inside a Python script. So this is just a little video of what it's going to be doing. Finished product, kind of get in your heads, and we'll go over what we did, and then we'll watch the video again so you can understand what you just did. So you can see we have an older version of Cisco AnyConnect running here. Say your management software goes ahead and pushes this package. I'm just doing it manually for this, you'll see here that we actually have some extra modules defined in that package. We'll go over how to add those to a third-party package. And it's running, it's installing the new version. And you can see here the user is actually connected to the VPN. At this point, you see the old icon down there. And then what we're doing is tailing the install log right here so you can see what's going on. And you can see a post install ran. So we're going to go over what this post install script does. And you can see the last line here is saying waiting for the plist to settle. So obviously we did something with the plist. And once cf D settles down, we can see in the same exact spot we have the new version. There's no question marks there. There's no user confusion where they have to go and find the new app, because Cisco named the app's completely different. This is Cisco Mobility Client, so it's not even the same name. You can get away with doing updates and stuff to like link because it's the same name, same path, no problem. But with running the old version of Cisco and then the new version, you would get the question mark and then the user calls and doesn't know where to find the new version. So let's go over how to do that. So you can see here that we added 2 extra things here. So this is the Cisco AnyConnect Secure Mobility Client installer that you would get from Cisco. They have these 4 by default. And what we're going to do is add additional packages, manipulate what packages from Cisco actually get installed, and if they're even user selectable. So if you handed this package to a user, if you didn't want them to even install web security, we can show you how you could just disable that altogether. And then we're going to go over the doc icon update script that did that fancy little doc icon switch out. Oops. And then we'll go over signing packages. That's super simple. Okay. So you get an installer from Cisco. Yep.
I just ask a quick question.
Sure.
I think you said you're using FileWave or Absolute Manage.
Absolute Manage. Mm-hmm.
So we use Monkey for our software, and we could do something. We could just do if we wanted to run that profile, that could be a separate package, just an update for Cisco.
Mm-hmm.
Or we could just run a package that just runs a script that symlinks the doc. What are the benefits of? You might get to this, but what are the benefits of actually modifying the original package?
Sure. So what I found very, very helpful, and us as sysadmins can definitely figure that stuff out, but there's a lot of people that basically, in our environment, is pretty distributed. So I'll build a package and hand it to someone, and they basically need it to be idiot proof. They're not going to have their own Monkey installation where they can go ahead and modify things and add post install scripts and make meta packages to do certain things. So basically we're able to package something up nicely, put it in a DMG, and put it on our software distribution web server, and all the clients that work for us can go download it, put it in their management software, and then just be done with it. So yeah, it's a great question. As MacAdmins, there's all kinds of different ways of doing this. This is a method that it's not talked about very much. I think I've never really seen someone take a package from a vendor, open it up, manipulate it, and put it back together. So that's why I wanted to go over this. I thought it was kind of neat. Any other questions before we get into manipulating this package?
You're talking the flat package here? Or I'm not familiar with AnyConnect. Is it a flat package? Or
Yeah, it's a flat package made by, when you look at the distribution plist, it's made by Package Maker, Apple's Package Maker. So there's also lots of different packaging applications out there. So if you get something from Cisco next year, if they change the way that they're building their package, this might not apply, and you might have to go in and find what type of tools they are using, because it might be a meta package or a different type of package than this flat signed package that they have distributing now. All right, so you first go ahead and first thing to do is take this package and we're going to expand it on out. So you get your DMG from Cisco, you mount it, and it's here's the path to it, and you use the executable called pkgutil and the parameter expand. Super simple. Pass in your source, your destination. So we're going to be working off of a folder that holds the contents of that Cisco package that we got. So here's what that looks like after we expand it on out. There's a couple things to note. There's these underscore modules.pkg, and these are funny little things if you ever have looked inside of these. They're not standalone packages. If you double click them, they won't run by themselves. They have to be called with this distribution parameter. This distribution XML plist has all kinds of other information about these modules, size and where its post flight is, and all that other kind of stuff. These aren't self-contained. And then we also see some resources which we don't have to mess with. But basically, right off the bat, we know if we want to add something else to this package, we're going to have to find a way to make some more of these underscore module PKGs. The easiest way I found was just to go ahead and use Package Maker that comes from Xcode. Just go to Apple's developer website and download it. You very well probably could use the command line to go ahead and generate these, or Rich Troughton has a couple of scripts to make payload-free packages, and that would probably work as well. But for the sake of simplicity, we'll just go with this example. Basically, in Package Maker, you always have to install something, even just to run a script. You can't really make a payload-free, at least I don't know how, to make a payload-free module. So I just put a screenshot in there just for the example here. And then what we really are after is running this post install script. This post install script we'll define later, but it's the thing that basically does the doc update for us. So you go ahead and build this in Package Maker. And we do the same thing that we just did with the output of that Package Maker package. We're going to go ahead and expand it, just like we did the Cisco app, the Cisco package. So we saved the doc module package to our desktop. We're going to go ahead and expand it on out, and this is what we get. Looks just like the Cisco one, but it's just not as much as information. So we have this desired module, which is by itself not really anything, but inside of a Package Maker package, it'll basically allow us to run that post install script. But we do have to go ahead and get a little bit of information out of this distribution plist, distribution XML file to pass over to the real Cisco distribution file that we're going to be manipulating later to actually make the changes. So the important thing that we need to grab from our created basically post install module is the install kilobyte size. There's other ways of generating what the size of that is, but I find it easiest just to see what Package Maker thinks it is. So we'll go ahead and note that number, and all we need to do then is basically copy that module that was inside of our expanded doc module post install package and copy it over to our Cisco expanded package. We're doing two things. We're doing the profile module at the same time, and also the doc one. I also renamed them to not be, screenshot, blah, 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 blah. We just call it doc module following their same naming convention. So now that we got these, the only last part that we have to edit is the distribution list. So it's pretty simple. We got I'm not even really sure what you would call these. They're kind of like just shells of a .pkg that is run from the real package. So then we just have to define these in the distribution plist. So we'll go ahead and do that. There's a number of places where you have to edit. So this is Cisco's distribution list. First thing you have to add is a choice, and then when you're in Package Maker, it's generating all of this for you. So when you add modules in Package Maker, what it's really doing is just basically generating this plist for you. So you add what you want. We're going to add our choice profile and our choice doc. Taking a step back, if you just wanted to modify a package that you get from someone that has the distribution, it's a distribution style package, you can come in here and under the choice area here, you can see if it's enabled or if it's selected. If it's enabled, basically it'll allow someone to manipulate it, turn it on or off. If it's selected, it's default selected and it'll install if you just run from the command line without giving it any parameters, or if you just click next, 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 it's going to install it. So you set here what you want to install and what you don't want to install, and what you want the users to be able to uncheck, and what users you don't want to check at all. So I went in here and turned off the web security, so I didn't want our users running that, and it's not selected. And we went ahead and added a new choice line for our choice profile. It's enabled, it's selected, give it a title, give it a description, and then this reference ID is the same reference ID that you called it in your original package maker file that we had the screenshot in. So as long as those are the same, that's fine. Add another one for the doc, same thing. Have a description, have the reference ID. And this is where we have to basically go ahead and have another reference. So this is kind of filling in the gaps to those modules, since they can't run by themselves. This distribution plist is getting some other information, what version it is, how large it is. You can see these numbers don't match because they were from different days and different times I was taking screenshots. But basically, you'll go ahead and put in that 128 if I was using that same module as I did earlier. And then the last part, this is the same file. It's just you gotta scroll down to get to this last part, and you kind of have to close things out. Simple as that. So once you do that, you flatten it back up. You basically give it the source, which is that desktop item, AnyConnect, it's a folder, and you rename it to whatever you want to, .pkg, and when you do that, you got a modified .pkg. You can sign it if you want to or not. It's super simple syntax as well. You say product sign, pass in your public cert name. It'll find it in your keychain if you have a developer installer cert from Apple. And then you tell it the source, and you tell it the destination. And it goes ahead and signs it for you and gives you a output of a signed package.
What's the difference between product sign and code sign?
How's that?
What's the difference between product sign and code sign?
As I understand it, product sign is for installer packages, and code sign is for executables inside of Xcode. So someone else can correct me if I'm wrong there, but I think it's the different types of things that you're doing. And there's different certs that you download and get from Apple for those different things. So now in the end, we have just by editing that distribution plist, you get this stuff. You can actually just edit the distribution plist and not even add those modules. They would fail and your package would fail, but basically you can muck around with the distribution plist just to kind of see what options you can add to packages. And we'll just play the video again. So now you can, actually, that doesn't help much. We already know what it does. Okay, how are we doing on time? 37 minutes left. We're chugging. So hopefully we'll get through this in the next 37 minutes. What we're going to go over is the doc icon update with Python. So we're going to go over that feature that you just saw. After it installs a new version of Cisco, it goes ahead and injects in that new doc icon. So one way you could do it is the user can manually drag the icon to the doc. That's not good. You'll get lots of calls. Doc utility tools. There's a lot of them out there, and some are better than the other. There's a good one. The name's blanking me right now, but it's a Python library that you can download and run to basically replace doc icon updates. Docutil, there it is. I found for this specific instance, it didn't work. And I know they're getting better, so I really want to go over the example of how to do it without this stuff, so you don't have to download or bring anything else with you, just whatever is on the operating system and whatever you can put in your script, this can go out to. So we're just going to go ahead and make a script that does this one doc icon replacement. You could do it for any other type of app that you want using the same model, but we're just going to give the example of the Cisco in this case. So we're going to do it in Python. First we define the interpreter. we go ahead and import the desired Python modules. We're going to be using all of these in our script. We'll go through them when we get to them. And like I said, try and stick, at least from a system administrator point of view, with the default modules that are available on the operating system. Once you start pulling in eggs and other things that you can do with Python, it gets real tricky to try to make sure everyone has the right version installed. So if you can, just use what's on the operating system. So this is our main. It looks like a lot, but it's really not. Similar to that bash script example, we're going to define a main function here, and the main function will kind of drive the rest of the script. Also in the main function, we're going to, this is probably not best practice, but we're also going to define our data that we're going to be using throughout the script. And we'll go through each part of this. It's pretty simple. So right here, define the Cisco AnyConnect Secure Mobility Client doc items. There's a lot, docutil, like Rich mentioned, basically allow you to generate this type of stuff. I just went in and made a hard-coded Python dictionary for 10.7, 10.8, 10.9 machines and 10.6 machines, but they follow, their doc follows a different standard as far as what a doc item looks like in the user's doc .plist. And the reason I hard-coded it here was we can just bring it with us. Basically, it's always in the script. We have what we want, and all we have to do is basically embed it in the user plist, and it'll replace out our the old version of the Cisco AnyConnect, and we'll put in the Secure Mobility Client. So there's lots of different ways of getting this. Basically, what I did was installed Cisco Mobility Client, put it in my doc, opened up my doc plist, and in Python just read that plist and printed it out, and then you can just paste in that information here. So in memory, this is what it looks like. It's pretty simple. All it is here's a variable called Cisco SMC 10.7, 10.8, 10.9 that basically tells us that this is the item that's going to go in the plist alongside all the other items that you have on your doc. You'll have Finder there, you'll have your downloads, and this is going to go in there. We're going to find where the old one is and replace it with this, basically. And then if you have a 10.6 machine, we're going to do 10.6 machines here, because their strings, you can see, don't have the same type of file path. I don't know why, but that's just how it is. So in the very first part of the main, we initialize 5 variables. Our first one, global bool, will set to false. And what this means is this is our global variable throughout the script. And if it ever changes to true, that means that we actually did something with a user on the system's plist. If it doesn't, we'll just leave it as false. That way, at the end of the script, we have a check to see if this is still false. We exit. If it's turned to true, we have to go ahead and clear out cfprefs d and then reboot the doc on the user, and that way it'll refresh and you'll see the new item there. So we already defined these, and then this is in doc plists. This string is how you identify the item. It's a dictionary, so it has a key and then a value associated with it. And this is what Cisco calls their doc item plist for 10.7, 10.8, 10.9 machines, and this is what they call the Cisco AnyConnect client for 10.6 machines. And this is, I should note, the old Cisco AnyConnect client. This is how we're going to find the old Cisco AnyConnect client. We're going to look through the plist and look for this key. So here's just a closer look at the 10.7, 10.8, 10.9, and the same thing for 10.6. It's pretty simple. You don't have to put a lot of information in here. There's lots of other things that when you look at the doc plist, if you ever open it up and look, there's a lot more things in here, but this is kind of like the bare minimum. You give it a path, it'll pull the icon from the path. You give it the file label, and that's about it. You also need the yeah, that's it that we need for here. The GUID, I'm still not sure about this, and the other guys that write the docutil stuff can probably talk more about this. I just made it 999 and then we generate a random one later. I'm not even sure if that has to be there. That might just autofill like some of the other things. Okay, so we have 10.6 and 10.7 versions. Basically, we have to figure out what version this specific installer is running on. That's the first method of business. So basically, this is a little bit of code that allows us to determine what version it's running on. There's lots of ways of doing this. This is the simplest I found for explaining what we're doing. There's probably a guy out there, probably even in this room, that can write a one-liner that will do the same thing. But this is kind of exhaustive, but it kind of gives a good look at what we're going at. Okay, we'll just go line by line real quick. This is a built-in, we imported earlier, platform. It's a built-in module that allows us to get at basically system profiler stuff inside of Python. So we get macver, and what it does is it actually returns three things. I forget what the other ones are. I think they're error values and maybe, I forget what the other thing is, but we really only want the first thing. And the first thing is 10.9.3, 10.9.4, whatever the version it is with periods, and it returns it as a string. So we go ahead and throw in an OS version variable here. These little underscores just basically mean that we don't care about the other variables it's returning. We're not going to do anything with them. But this way, at least it won't give us an error. So once we have that OS version, actually, I have some better slides that show us what's going on here. So we get our OS version. This is what it looks like in memory right away. We have 10.9.4. We go ahead and run replace every period with nothing. We get this. What we want to be able to do is turn it into an integer so we can make some mathematical decisions on this. So the next thing we'll do is we'll call our int function that basically takes a string and gives you an integer. If you pass in the word Tom into this will throw an error and your script will exit. So you got to be careful what you put in there. You got to know it's going to be some type of integer in the end. There's great ways of catching errors and sanity checking what you're putting in here, but for our example, we're just going to go ahead and do it. So we give it OS version, and this little guy right here, these brackets, is a great way of explaining string manipulation. So basically, we're going to get from the zeromost point of the string to the third point in the string, which is kind of similar to cut in Bash if you're used to that. So what it does is just gives us the first three values in that string. So now we have the number 109, which is now an integer. And since it's an integer, we can make some decisions based on it. So super simple. If the OS version is equal to 106, and I guess typically with this could still be a string because they would be the same. 106 string could look at this, but this we want it to be an integer because we're doing less than or equal to. You can't do that with a string. So 10.7, 10.8, 10.9, 10.10, all of those would equal true, and it would run this bit of code instead of running this bit of code. And all this does is assign the proper 10.7, 10.8, 10.9 dictionary that we defined earlier, that's going to be our plist item, into our and our CF URL string of how we're going to find the old version, because both of them were named differently, as you saw. Okay, so here's the state of our script after making a few required decisions. So we have our global defined in main, and that's fine, that's fine. But our new items are, we actually have a CF URL string, and we know that this is going to, since it's a 10.7 plus machine, that's the format that we're going to be looking for the old version of Cisco. And we have a pointer to our dictionary that we're going to replace it with, called Cisco SMC. And we'll use these variables later on when we actually do the injecting of that plist into the user's doc item. So now that we have those, we can move on. So the next part of main is to run some functions, but we haven't really defined what list users is, read doc user plist, reload doc, or bash command do yet. We kind of talked about bash command earlier, but this script doesn't know what these are yet, so it won't actually run these. Remember, we're still in main, so we're just basically defining the function, and we'll run it later. So let's go ahead and define the other functions that we use, and we'll come back to this to finish up the script. So next thing we need to do is get a list of all the users. We don't just want to do the current running user. If there's other users on the system that have that old doc icon plist in it, we want to go and grab them too and update theirs. So next time they log in, they'll see the new icon rather than a question mark. So again, this is probably not the best way to do this, but it works for our purposes. We go ahead and use the OS module, and we're going to go ahead and list dir. It's kind of just similar to ls in bash. And we're going to list the directory /users. This basically creates a list for us, and it assigns it to this all list users home folder variable. We create another blank list called dirs to exclude, because when we list users, you know, there's things in there that we don't really want to be looking inside of. So we have another for loop to go through every user that is in this list. And actually, before I do that, I have a nice visualized Python example for you so you can see what it looks like. Can you see that okay? Yeah. So what I've done is just preloaded all user home folders with some information, because obviously this website can't read what users I have on my system. So it has I have a .items, a .localized, some of the things that you would find in a user folder. I have a user called Tom, shared, and Zach. Okay. Back. So when we execute this first program, we see, oh yeah, we got a list here called all users with home folders. The next item, dirs to exclude, is just an empty list. We're going to try and basically grab these items and add them to the dirs to exclude so we can exclude them later on from looking in. So the for loop will go ahead and basically take the first item of the list, assign it to E, and then go through this little block of code. So we'll see that happen. E, right here, gets the first item in this list, and it'll go through as many items as there are and assign E each one. So basically what we're going to do with E is, if there's a period in our E item, we're going to go ahead and add it to the dirs to exclude. So we don't want to be looking in any hidden folders. So we'll see here that that is actually true, because the arrow moved down and it's going to execute this piece of code next. And all of a sudden, oh good, we have an item in our dirs to exclude now from this append command. And then you see it goes right back up to the top, and it's going to do this again for the second item in the list. And next we'll see E be populated with .localized. And that's what it does. So it goes through and gets the second item. And we go through, and same thing, oh, there's a period in our E, so it's going to go ahead and add that to our dirs to exclude. The next one, it'll go ahead and assign E to Tom. Tom obviously does not have a period in it, so it's going to go right back up to the top and not do anything else. Same thing for the rest of the items in there, because they're really good users. So then we come down here, we have our dirs to exclude. We want to basically take these and remove them from here. Now that I'm thinking about it, probably the easiest way to do is, instead of adding them to a new list, is just remove these items from the list when we find them by index number, but since we got this for loop here, we'll just do it. So it's going to go ahead and do the same thing. It's going to loop through this DIRs to exclude list, which is only too long, so it'll do it 2 times. And it's going to remove our whatever element we're on from our all users home folders. So here's our all user home folders, and basically our E is item, so the next line that we execute is going to go ahead and remove that from our main list of real users. Excuse me. It's going to do that for that localized. So we end up with all users with home folders is actually now a list of all of the users on our file system that has home folders. And then we return that so we can use it in main. That makes sense to everybody? Any questions up to this point? How's that?
How would you exclude the shared folder?
Oh, basically you would just go ahead and add another if statement here for if shared in there, or since we always know shared is called shared, we would just go ahead and say maybe at the last line before return, if shared's in here, remove it too. Yep.
I just wanted to mention, as far as that goes, for a best practice, you probably don't want to list your users by going through the users folder because there's possibly users other places. So
yeah.
You probably would want to do it a different way, like DSCL or something, and then you wouldn't have to worry about the shared or localized stuff.
That's very true.
In the real world.
Yeah. Because there's lots of other places you can store your users on a separate partition or wherever else you want. For our purposes, this is perfectly acceptable. Okay. So now we got our list of users. We got the basically the key that we're going to be looking for in the plist for the old version of the Cisco app. And we have the dictionary that we're going to be inserting and replacing the old version with. We can go and get into the meat of the project, which is a function called read users doc plist, which is, it does more than read. It actually does the replacing too, but it's just what I named it. And this is, I'm not proud of this, but this is just a good example of how to check if the plist exists. There's much better ways to actually try and parse the plist and make sure it's a plist rather than just a file, but we'll just go through this. We have 18 minutes left. Basically, we're looking to make sure the plist exists. We do this by checking the path to see if it's a file. If it isn't a file, it would return false, and then this would be, it would be basically running this else block here, and there's no plist in the user. So we have the user, but maybe they haven't logged in yet, or maybe it's the shared. Oh yeah, that's true. The shared would be handled right here because it doesn't have a doc plist, so that's fine. And it would go ahead and skip whatever part in that user of the users list. It would exit at this point with the return. So if it doesn't have a doc plist, there's nothing else we have to do for that user. We'll move on to the next user. So this next section is pretty cool. I'm fairly new to pulling in Objective-C or Cocoa or Foundation methods into Python, but Python has the ability to do it. So we're able to basically leverage some of the awesome things that the Cocoa and Objective-C have available in the Objective-C and now the Swift language, and pull it into Python and use some of those functions that Apple has built into the system. So what do we know about the doc utility plist, the doc plist? It's stored in the Apple binary format, and as many people probably know, this guy, it gets in the way a lot. You manipulate a plist with defaults, and then all of a sudden it comes back, or you delete a plist, you think it's gone, and then CFpref dumps it back there for you. So it's a big headache, so we'll work around that guy too. There's actually some cool work being done with interfacing with this directly with Python too. I haven't looked much into it, but I think some other guys here probably know more about that. Anyway, OS X has a great way of handling Apple binaryplists. It's built into the Foundation framework, and we can take advantage of it. So just looking at the other options we have, which I've used in the past to varying success, you could use the PL-util convert. This is great if you're in bash scripts. You can just convert it on the file system, read it in, manipulate with set or whatever you're going to do, and then write it back and then convert it back to binary. But it's not good for our uses because CF will still get in the way, especially with the doc. plist buddy can actually directly read and write binary plist, which is nice. However, to get it into the type of format we need in Python, this is not the best choice. So we're going to use a class that Apple provides to us called NSProperty list serialization, which basically is just a fancy way of saying reading the binary plist and writing a binary plist. Takes as input binary and outputs a plist that we can do stuff with. And then we can give that with this method here. We can go ahead and pass in a clear text plist, for lack of better words, and it'll go ahead and put it in the Apple binary plist format, and then we can write it back to the disk. Something to note here is when looking at the Apple documentation, I've kind of noticed a trend where you have the class here, you have the method, and the method, if you're used to programming Objective-C, you put a lot of colons for the types of for the next type of parameters that's going to be taken in. But in Python, it just replaces that syntax with the underscore. The program we're using here called I forget what it's called now, PyCharm. It has a lot of code completion, but if you go ahead and import this module, or this this module, I guess you'd call it, it doesn't really do good code completion for this Objective-C stuff, so you kind of have to go look at that back at the Apple documentation of what it needs. So this property list with data options format error method takes in plist data, which is binary Apple plist, and then a format of what you want it to output as, and we're going to format it as just an XML format so we can read and write it. So basically what we're doing is opening the file raw. The user %s represents this user right here, so it'll just pass in whatever current user we're on, and it'll read in this binary Apple plist. We have to buffer the data. Essentially what that does is allows us to not use the NS data data type, which this requires. It puts it in a format that this Apple method can understand. And then we run this Apple method, which basically is just a fancy way of taking in a binary plist and returning to us a nice, easy Python dictionary. So if we were to print this, it would be our whole user's doc plist, but it would be in a nice Python dictionary format that we can do stuff with. And I'm not going to go through that because we don't have enough time. Okay, so now we have, actually I have it already pulled up so I can show you what it looks like, because it doesn't make much sense without it. So this is going to print the plist. So this is what we pull in. We see all of our doc modules. Here we see our terminal, we see our JetBrains, iWork, LandRev, and there's our Cisco mobile client. And that bundle identifier, the CF URL string is what we're going to use to identify. Actually, no, we're going to use the bundle identifier, I believe, to identify what the old item is, and we're going to replace it with the new item. So that's just to give you an idea what in Python now we're looking at and how we're going to be able to manipulate this previously binary plist. Now we have it in Python and we can actually get a hold of it. So now that we have the docplist as a Python dictionary, we can manipulate it. This is a simple way of going through and basically finding what we need. We need to go into the persistent apps, which is a part of that Apple plist dictionary. We need to go to the item that we're at. So the I is a counter. So this helps us keep track along the doc where we are. We don't want to basically, if it's here, we don't want to replace it with all the way over by the trash. We want to replace it exactly where it is. So the doc, this I will keep track of where we are on the doc. And once it finds it, this is just some sanity checking, or is there some doc icon things from like Microsoft that don't follow this format, and they'll have, you know, title data -2 in there or something, and then your script will fail because it comes across a key it can't read. So if we try it, if there's a key error, then it just skips that item on the doc. But Cisco uses this format, so that's good. So once it finds, it basically looks through the whole doc on the user plist. Once it finds it, it will run this bit of code that basically goes ahead and replaces the GUID with a generated GUID. It goes into the persistent apps I, wherever we were on the doc, and just simply replaces that whole thing. So whatever the old one was, it's just going to become that new dictionary that we defined all the way up in the beginning, based on if it's 10.6 or a 10.9 machine. Just give some output to the script saying, hey, we found it, we're going to update it. And then what we do is, this may not be necessary, but it definitely helps, remove the docplist completely. Since we have a good copy in memory, a good copy of it, we're going to go ahead and then basically deserialize, I guess you'll call it, our doc using the Apple method. We take in it passes in the nice clean plist, which is D here, and then it goes ahead and outputs the binary version. So now we have our plist data again, and then we just have to write that to the file system. So it just writes it right where it found it, and sets the global to true, like we were talking about earlier, because it did something. If it doesn't do anything, it's not going to make a difference. Here's some forwarding functions. We don't have enough time to go over them, just like how it generates the GUID and what it does. Actually, the reload doc's kind of helpful. This is just a percentage loop. It doesn't really do anything functional-wise. But basically, this command right here, cfprefd, right before restarting the doc, I found that if you just kill cfprefd, it won't mess up your recently written doc plist. So it all happens within, I actually give it about 20 seconds, I think. So it loops through this 100 times at 0.2 seconds. It gives it about 20 seconds of work. So just let it settle. I found that if you give it 5 seconds, cfprefd will go ahead and replace it, and then all your work is for naught. So just giving it like 20 seconds, then kill cfprefd, then restart the doc, and everything works great. And now we're back to main. So basically, if the global's true, reload the doc. If it's false, just exit the script, nothing happened. So we don't have to change anything. The user wasn't running it, or it wasn't in the doc. Well, this is informative. Basically, just goes through every user and does what we just did. And the global bool, and that's it. So basically, sweet, we got through that whole thing. That's great. Basically, that goes through the script, and I didn't really document how you would put this into a package. It's super simple. If you've ever done a post install package using Composer or Package Maker, I showed the package maker example, but Composer, you would just add a post install script onto this, and it would go ahead and run right after the fact. But that's it for this session. Sorry there wasn't enough time for very many questions. Next session we're going to go over the Cisco, the recreating the Casper suite. But any questions in our last couple minutes? Yep. Yeah.
The weirdness that you saw there. So since the introduction of that, Apple has said that the storing of preference keys in lists they consider to be a private implementation detail, right? Which means when 1010 ships or 1011 ships, suddenly all of your preferences might be in a SQLite database, right?
Yeah.
They're saying we cannot guarantee going forward that we're going to continue to store these values in key lists. So I just want to warn that if you're doing direct key list manipulation, I think you have the potential for that to suddenly just stop working.
Exactly. Yeah.
Python has CS references APIs.
Mhm.
If you're already that deep in Python, you might want to consider going that route instead. It might be safer.
Okay, that's a great tip for sure. Yeah, like I said, I know there's smarter people in this room that have figured this stuff out.
I don't want something to suddenly break that Apple changes.
Yeah, that's great. Thanks all.